Okay, let's work through a quick example here. We've got a couple of points in 3D space, A and B, and we've rotated 3D space around sufficiently that it looks like we're looking right onto the plane there. You're allowed to do that. And we've got to find the vector equation of this line L, the parametric equation, the Cartesian equation as well. Let's start with the vector equation. So if we want to describe any point on this line, remember that will be given by this position vector here, R. And R is the same thing as taking a journey along A and then a certain number of B's. Okay, so this vector R is going to be the vector A plus a certain number of this direction vector B. Now, what are each of these pieces that we need? So A, let's work on A first. So the vector A, we can find it by thinking about where we ended and when we started. So we ended at 1, 3, and -1, and we started in each case at 0, 0, 0. So that's simply going to be 1, 3, and -1 here. And the vector B is going to be, well, a good one would be to just consider the vector from capital A to capital B. So again, it's going to be a case of where we ended minus where we started. Think about where we ended. So 3, and then we started at 1. So it's 3 take 1. So that is going to be a 2 right here. And then it's where we ended minus where we started. So 0 take 3 gives us -3. And where we ended minus where we started. So I've got to be really careful here when I'm doing this. It's 1 minus -1. So it's 1 plus 1. Okay. And then we simply put it together and we've got what we want. So down here, this is 1, 3, -1 plus a certain number of these b's here. So 2 -3, 2. And it's good practice, I think, to say, okay, but what is this lambda that we're introducing? Don't leave people hanging, sort of let them know what it is. It's just some real number. And you can think of it as time, I guess. So as time evolves, we get more and more points on this line, something like that. Okay, so that would be the vector equation of the line L. Let's go and just have a quick look in GeoGebra and see if we can replicate that. What happened there? That's weird. Don't know what happened there. So let's put in these points. So the point A is 1, 3, -1, I think it was. And the point B is 3, 0, 1. There are the 2 points. And to put the line between them, just use the line command, I think, like that. And there is our straight line. And it's actually going to report that straight line in vector form. So it's saying that straight line here is given by, you start off with 1, 3, -1, and then you add lambda lots of 2, -3, 2. 2, -3, 2, 1, 3, -1. That's a good way of checking your answers and seeing how it all looks in 3D. Okay, in terms of the parametric equations now, all we're doing is we're considering these component-wise. So the parametric equations are going to be, let's do it over here. So what's x going to be described as? X is going to be 1 plus 2 lambda. Because remember that, as I've said before, this vector r, the position vector r, is just sort of, it has general components x, y, and z. So x is going to be equal to 1 plus 2 lambda. There's our first equation, our first parametric equation. Y is going to be 3, take 3 lambda, and z is going to be -1 plus 2 lambda. And if you hadn't told anyone to date what lambda was, it would be a good idea to say that, lambda is a real number. Just, again, you want to be clear about everything. You don't want people to be wondering, well, what are you talking about there? And that's the parametric equations. And then the Cartesian equation, you can solve for lambda in each of these and then set each of those lambdas equal to each other. So let's quickly do that. If we solve for lambda in this first equation, it's going to be x minus 1 divided by 2. So x minus 1 divided by 2. And we'll set that equal to the next lambda that we're going to get. So let's work on this one here. So that's going to be y minus 3 divided by minus 3. Y minus 3 divided by minus 3. And then lastly, when we go and look at that equation, it's going to be z plus 1 divided by 2. Z plus 1 divided by 2. So there are our Cartesian equations of the line L. 3 different ways of looking at the same geometric object.